Okay, so we're continuing on with section 4.2. So the first thing we're going to look at is as follows. It says bound the area of the shaded region by approximating the upper and lower sums. So basically what's ending up happening is you're wanting to find the area of this pink region. So in order to do that, what we can do is we can find the area of an upper sum and a lower sum, and then we know that the area of the pink region is somewhere in between the two. Now when I hear the word upper, what that means is that means above. Okay? And so what I'm going to do is I'm going to break these into rectangles. Okay? So the first rectangle, and notice they tell me to use rectangles of width 1. So notice here I'm going to end up drawing how many rectangles? 4. So the first one I'm going to find is the upper sum. So what that means is here's my width. Now I got to figure out how high I'm going to go. So I'm going to go up until I hit this point right here. I'm going to go to the left. And what do you know about that rectangle? It's a 1 by 3. So the area of that rectangle is 3. So here's my upper sum that I'm calculating because it is in fact above the graph. So we've got a 3. Okay? Now I'm going to do the same thing from 1 to 2. So here's my width, and my height here will go up how high? 4. So my area of that region is 4. Okay. My next one will be how high? How high? 4.5. So we'll call it 4.5. And then what about the last one? 5. Okay. So my upper sum here, if I add all those together, my upper sum here is 16.5. So what that tells me is that the area of the pink region is somewhat below 16.5. It's not bigger than that. Okay? So now we're going to find the lower sum. So the lower sum means I'm going to look at rectangles that are actually beneath the curve. And so the best way to think about the lower sum is I'm going to do the same width for the rectangles, except for I'm actually going to go up here to this point, and I'm going to use the previous y value. Okay? Now this one, it's kind of hard to see, but on the next one I think you'll see a little bit better. So what's the area of this rectangle? 1. So now here's my width. My height on this rectangle, actually, if you notice, I'm going to go up to the previous value. So what's the area of that one going to be? 3. This one, I'm going to go up to the previous value. 4. And this one, I'm going to go up to the previous value, which is 4.5. So I know that the area underneath that curve is somewhere between those two values. Now this is the thing, if I would have used smaller rectangles, my area would be more precise, right? Because I mean obviously width of 1, if I would have done a width of like a half or a width of a 4th, it's going to be more precise. Okay? And so we're going to look at how you can find the area under a curve by drawing rectangles. That's going to be our task for today. Okay? So if you notice this one, it says use the 5 rectangles, here's the figure, and find 2 approximations of the area of the region lying between the graph of f of x equals negative x squared plus 5 and the x-axis between x equals 0 and x equals 2. Now we're going to actually kind of do this a little bit different than is normally presented, because I think if we kind of build on what we had the previous slide, I think you'll understand things a little bit more when we get going. So what kind of rectangles are these right here that you see?
1 rectangle.
Yeah, but I mean under. Yeah, it's the lower. So this is the lower. So understand there's also another one, which are the upper rectangles. And so what we're going to do is find the area of each of these. So let's go ahead and start. What's the width of this rectangle? 2/5. Okay, so this is going to be my first area, my rectangle. Here's the width. Now I got to figure out the height here. What's the height going to be here?
4.75.
Yep. the height is actually this value on the graph, right? That value on the graph will be the y value at 2/5. So it's actually going to be f of 2/5. Okay, so f of 2/5. So how you find f of 2/5 is you're going to plug in 2/5 for x in the original formula. So in this case, I'm going to take negative 2/5 squared and add 5.
121 over 25.
Okay, so basically I end up having 2/5 times 121 over 25, which when you calculate that comes out to be 242 over 125. Good. Now what I'm going to do is I'm going to do the same thing with the next triangle, our rectangle. And the width of this rectangle is what? 2/5 again. And let's figure out the height. What's the height of this rectangle going to be? It's going to be f at 4/5. So I've got 2/5 times, yeah, what? Yep, 109 over 25, which is 218 over 125. Good. Now, for those of you that are wondering where did the 109 over 25 come from, basically I'm doing negative 4/5 squared plus 5, because that's what the equation states. So on the next one, the width of the rectangle is what? 2/5. And I'm going to take that times f of, so how high is that one going to be? 6/5. So I'm going to find f of 6/5. So you should be noticing a pattern. So what do we have? Perfect. So I should get 178 over 125. Okay. So 2/5, and then f at what? 8/5. Okay. Which should be 2/5 times, yep, 61 over 25, which is 122. And then last but not least, my width of this one will also be 2/5 again. The height will be f at what? 10/5 or 2. You could do f of 2 because that's what 10/5 is. So 2/5 and then f of 2. So you take 2/5 and then times what? 1. So now if I want to find the area of all those rectangles, I'm just going to add those 5 values up. And when I add those 5 values up, what do I end up getting? Which is approximately 6.48. Okay. So would the real area underneath that curve be smaller than 6.48 or bigger than 6.48? Bigger. Because notice I'm doing underneath the curve. Okay, so the true area of the pink is going to be bigger.
I thought we found the area of the purple.
Okay.
So
Let's
what,
go.
Wait, what would be the boxed answer now?
162 over 25.
That's, yeah, it'd be, yeah.
Oh.
Okay, let's look at this next one. Okay. Now this next one, what kind of rectangles are these? This would be like the upper sum. Okay, that other one would be like the lower sum. So let's go ahead and start. So first rectangle, width of what? Times. That's f of 2/5. What is it actually f of? It's this point on the graph right here, which is f of what? 0.
What?
It's the value at 0. It's the previous value. So this is actually f of 0, which in fact is 5. I get that. Okay? But it's important to understand the f of 0 because that'll help you for the next one. So now this one, the width is 2/5 again, and the height is, it's not f at 4/5 because that's where f of 4/5 is. It's actually f of 2/5. Okay? Now you already have f of 2/5 from the previous problem, so what you actually could do is you could go back to when we found f of 2/5 on the previous problem. And 2/5 times f of 2/5 from the previous page was what? 242 over 125. Good. Okay. Okay. So what's the width of this one? 2/5. The height is what?
4/5.
F at 4/5. So let's go ahead and go back to our previous one, and what did we find that area to be? Yep, over 125. Okay, next one will be 2/5 times what? F of 6/5. 178 over 125. Good. And then the last one. 2/5 times f of 8/5, which is, okay. So what would this sum be? Which is? (202 over 25). So what type of sum is this known as again? The upper sum. So obviously we know that the area of that, the true area of that is somewhere between 6.48 and 8.08.
Whoa.
So let's go ahead and look at the next slide here. The next slide basically says, if you look at this, let's look at this diagram. It says the area of the inscribed regions is less than the area of the region. Okay, we've looked at that. You've got the true area of the region, and in this case, the area of the circumscribed rectangles is greater than the area of the region. Now notice this conclusion, and this should make sense. As n increases, and when we say n, that means the number of the rectangles that we have. So as you use more rectangles, both the lower sum and the upper sum become closer to the actual area. So if we did, on that previous slide, we had 5 rectangles. If we chose to do 10 rectangles on each of those, what's going to happen is that area is going to get closer and closer to the actual area underneath that curve. So if we did 10 rectangles, you're not going to get 8.08, you're going to get something less than 8.08 and something more than 6.48.
So by finding, if you had like double the rectangles, you could find, right, using how much closer each one is, you can find the exact number.
It's not always proportional. Okay, so now what we're going to do is we're going to look at, instead of using a specified number of rectangles, we're actually going to look at the true area. Okay, so we're going to look at as many rectangles as we can fit in there as possible. And so we call this the lower sum and the upper sum. Now this is where you kind of need to pay attention. Okay, I'm going to warn you. All right, so first of all, it says find the upper and lower sums for the region bounded by the graph of f of x equals x squared and the x-axis between x equals 0 and x equals 2. Okay, now notice what it says here, delta x equals b minus a over n. B in this case is 2, because that's what x equals. And x equals 0 is a. Okay, so in this case, b minus a is 2 minus 0. So it's going to basically be your endpoints. So 2 minus 0 divided by n. So that gives me 2 over n. And this is the width of the rectangle, or rectangles. Okay, now I don't have a specified width like I did 2/5 on each one because I'm doing all the possible rectangles. And so now what we're going to do in this problem is we're going to find the lower sum. All right, so I know that the area of a rectangle, okay, is width times height, or length times width, same thing. Okay, and so what I'm going to do now is I'm going to actually find the height of the rectangles. Okay, so let's go ahead and look at this. Here I am at 2, right? What is the height of this rectangle? Is it f of 2 like I found? No, it's not f of 2. It's actually the previous value of x, right? It was kind of like when we did that, when we did the 2/5, it was f of 0, and then it was always that previous value. So like right here, if I look at this next one, this one right here, it's not the height here at this, because the height at this is actually, okay, oops, I wrote that up too high. It's actually going to be the previous value of x. So this is how we represent it. This is where things get a little tough to understand. Okay? How I represent this is in order to move back to the previous one, I'm going to use I minus 1. And I refers to the rectangle that you're talking about. Now the other thing you need to attach is the width of the rectangle. And so in this case here I've got my 2 over n. So this right here is the height of the rectangle. So let's go through that again. The I minus 1 refers to going back to the previous value. You will always include the width, the 2 over n, in there as well. Okay? Now, if I would have been at the correct height, I would have just used I. If I would have had to go back one. Okay, so then now what's going to happen is I've got the width and I've got the height. That's what I have here. So if I'm going to go ahead and there's my width, and I'm going to take that times the height. Now the height is actually the f value. That's the y value of the graph. Okay. Oops, I forgot another set of parentheses. So I've got width times height. Now in this case, I want all the possible values. So I am going to sum up every possible value. So this means all the possible rectangles. So when I put that sum, that's all the possible rectangles I can have. So I've got the area, width times height. This is all the possible rectangles, so it's adding them all up. Okay? Like I said, this is where it gets a little bit interesting. So then now, what I need to do, okay, is I'm going to go ahead and leave the sigma. And I'm already running out of room. Okay, I've got my 2 over n right here. Okay? Now here, when this says f of, that means the original function, which in this case is the original function squared. So what that means is that I've got 2. I'm going to go ahead and distribute that 2 to each of these. Okay, so 2i minus 2 over n. And I'm going to square that because I'm putting it into the function. Now if that had been like x cubed, you would have had like 2i minus 2 over n cubed. Okay? So now, next step, what I need to do is go ahead and square that. Come up with something. Okay? So I've got my 2 over n. If I square this, that means you take it times itself, right? So let's go ahead and FOIL that out. What do you get when you FOIL it out? You've got to do first, outer, inner, last. n squared. So 2i times 2i is 4i squared. Your outer will give me what? Inner will give me. So it's really a negative 8i. And then plus 4 all over n squared. Okay? Now what I'm going to go ahead and do is I'm going to go ahead and combine those. So I'm going to combine the 2 over n with all of those. So I've got n, I equals 1. In this case, I've got 8i squared minus 16i plus 8 all over n cubed. Okay. Now, you're probably going to have to write to the right. Hopefully you left a lot of room. Okay, because, yeah, I have to do two columns. Okay, so then now what I'm going to go ahead and do, all right, I'm going to go ahead and, in my next step, I'm going to take out what's in common on the top. And what's in common on the top? What? 8. Okay, and I'm also going to take out an n cubed. So when I take out that 8, what am I left with? I'm left with, if I take an 8 out, I squared, yep, 2i, and then what?
Plus 1.
Plus 1. Okay, now I'm going to go ahead and make some more room for myself here to write on. Okay. So now what I'm going to do is I'm going to get rid of that n for right now. So I'm just going to kind of move it outside of the sigma. So I've got 8 over n cubed I'm going to put here. I've still got my sigma here out front. Okay, and then I've got my I squared minus 2i plus 1. Yes. Now, what we're going to do here is we're going to utilize those summation formulas that we learned 2 days ago. Okay, this is the sum of I squared. This is the sum of negative 2i. This is the sum of 1. So I squared, if you remember, was n times n plus 1 times 2n plus 1 all over 6.
You're on the printer, right?
Okay, no, he's ready for the I one. He was just jumping ahead. So I've got minus 2. The sum of I is n times n plus 1 over 2. And then the sum of 1 was 1n. Now notice I got rid of the summation notation because once you actually plug those formulas in, you're done with the sigma. Now this is what we're going to do instead of kind of doing our work. Here, I'm going to go ahead and multiply this out over here on the left. Okay, so basically I've got n squared plus n times 2n plus 1. You see where I got the n squared plus n? You distribute the n here, and then I'm going to take it times 2n plus 1. So how do I multiply that out? FOIL. So let's start. What do you get? 2n cubed plus, which is 3n squared plus n. Okay. So that's what that will simplify to be. So I've got 2n cubed over 6 plus 3n squared over 6 plus n over 6. Okay. Minus. What am I going to do here? Distribute. So I get 2n squared over 2 minus 2n over 2. Okay, so now what I'm going to do is combine like terms if I can. So first of all, I've got 8 over n cubed, and then we'll be almost done. Here's my 2n squared over, or 2n cubed over 6, which is actually n cubed over 3. Okay, is there another n squared here? Yeah. So this is 1, this is 2, so it's basically 1/2 n squared minus 1n squared. So what's 1/2 minus 1? What's 1/2 minus 1? It's 1/2, so it'd be n squared over 2. Okay? And then this one will be n over 6. And you're probably wondering, why didn't I do anything with these back two? Well, because this is negative n plus n. So what ends up happening to those? They cancel. Okay, what do you think you're going to do now? Oh, well, what am I going to do here with the purple? Distribute. So I'm going to distribute to each of the 3. Okay, so 8n cubed times over 3n cubed is just going to be 8 over 3. Okay? Because the n cubed cancel, right? So then here I've got 8n squared over 2n cubed, so net result will be 4 over n. And then 8 over n cubed plus, or times n over 6 should be 4, 3, you're right, it would have been 8 over 6 and then just reduce it in, 4 over 3n squared. That is your,
So it's just simplifying.
yes,
Now
So-
that you say like that, it's easy.
Don't we need to
So what happened to the?
solve it?
the minus n squared. This is 1/2 n squared. This is minus n squared. So 1/2, oh, that should be a negative. Is that what you're saying? That should be a negative? No, it shouldn't be.
Oh, no, I don't.
Oh, it should have been negative, because 1/2 minus 1 would have been negative.
Yeah, that one should have been a negative. I think we forgot that negative sign.
Yeah.
Yeah. This should, no, all you have to do is put a negative in. That one should have been a negative 1/2. Well, you should have said something. I missed that one. Okay. All right, so that's your lower sum. Now, I'll be honest with you. That's the tougher one of the two. Okay?
I feel like you just simplified. The whole process was just simplified.
A lot of it is. Okay, now we're going to look at the upper sums. Okay, now I'm going to be honest with you. One of the ones is the tougher of the two. One of the ones is the easier of the two. We did the tougher one to start with. This is the easier one of the two. Okay, so first of all, upper sum. I've got my width of my rectangle. My width of my rectangle from the previous problem was 2 over n. Okay, so I've still got my width here. Now I've got to find the height of each rectangle. So let's go ahead and just look at 2. At 2, what is the height of this rectangle? The height of this rectangle is f of 2, right? So is that dealing with the previous one? No, it's dealing with the, so in this case, it's just going to be I. And then what do I always make sure I take? I multiply by the width. So I always multiply by the 2 over n, or whatever the width is. Okay? So in this case, I'm going to take 2 over n times f of 2I over n. So I'm still summing because at 2, the height is in fact f of 2, so it's that correct height. It's the value at your x
So
value.
anytime there's an upper sum, it's going to be...
Not in, no, it depends. That's why you have to kind of draw it out. So what I like to do is pick a value. So in this case, I picked 2. And I said, okay, at 2, the height is in fact at, the f of 2.
I thought it was intersects, isn't it?
Yes. Okay, so let's go ahead. F of 2I over n means I've got 2I over n quantity squared because my original function, remember, was x squared. So I'm just plugging in that 2I over n into that. Okay. All right, so let's go to work. 2I squared over n is our 2I quantity squared will give me 4I squared over n squared. distribute it, so what do I end up getting? 8i squared over n cubed. So now what I'm going to do is I'm going to eliminate the 8 and eliminate the n cubed. Reason being, it'll be a lot easier to simplify if I get those out of the way. So I'm going to move the 8 over n cubed out front. So whatever constant you have, whatever n you have, that's what you move out. Everything else stays inside. So in this case, I'm going to sum I squared. Okay? So now it's time to get rid of the sigma. So what is the sum of I squared? Now what I'm going to do is utilize my information from the previous slide. Okay, so we already know that this FOILed out to be will give me 2, oops, let's go ahead and do my 8 and yep, 2 n cubed over 6, and then plus 3n squared over 6, and then plus n over 6. So now what I need to do is distribute those. So 8 times 2 is 16 over 6, which should be 8 over 3. And then you each have an n cubed. Okay. 3 over 6, 1 over 2. So I end up getting 4 over n. And then in this case, I get 4 over 3n squared. It's almost the same thing. The difference is that I believe the one was negative. There was a negative 4 over n on the previous slide, not a positive 4 over n. So the upper and the lower, that's how you find the two sums. That's one problem.
Perfect.
Okay.
We have like 2 of these on our test. And
Now, what we're going to do tomorrow, okay, tomorrow we're going to continue with this next one right here, and this is where we're going to end. Okay, and this will be the end of the section. You already have your assignment. You're probably not going to be able to do 47 through 49. So if you want to go ahead and get started and get 23 through 30 done, those are like the first few we look at. And then we will go ahead and finish with that last problem tomorrow.